2004, the desert. Temperatures pushing 110 degrees Fahrenheit, and right in the middle of all that sand, a massive construction site behind tall fences. On the blueprints, a tower so tall that even seasoned engineers thought it was a joke. A skyscraper? On sand? You can't be serious. But the people behind it had a plan. They weren't satisfied being just another rich city in the Persian Gulf. They needed a symbol, something that would pull them out of the shadow of their oil-rich neighbors, something that even 50 years from now would mean one thing. This is Dubai. The original plan called for a 550-meter tower, then 750, and then they decided to build something no one could ever catch up to. And so, in a place where there's no bedrock even 100 meters down, where the heat turns metal into a hot plate, they set out to build a vertical city, nearly a kilometer into the sky. Today, this building holds over a dozen world records, and from the top, you can watch the sunset twice in one evening. But getting there meant solving hundreds of engineering problems, and doing things that had never been done before. Why do people compete to build the tallest structures anyway? For 4,000 years, the Great Pyramid of Giza held the record at 145 meters. It wasn't until the 14th century that an English cathedral surpassed it at 160 meters. Then the record bounced between churches until 1889, when the Eiffel Tower took the crown at over 300 meters. The 20th century brought the real skyscraper wars. Chicago, New York, the World Trade Center at 417 meters. Then the Petronas Towers in Malaysia at 452 meters in '98. In 2004, when the first foundation piles of the Burj Khalifa were being driven into the Dubai sand, there was already a reigning champion, Taipei 101 in Taiwan, standing at 508 meters. Back in the early 2000s, Dubai ran on oil, but the leadership knew the golden age wouldn't last forever. The city was growing, but the economy depended too heavily on a single resource. Sheikh Mohammed bin Rashid Al Maktoum was thinking strategically. If we don't want to be wiped off the map, we need to make Dubai a capital of tourism, business, investment, and luxury. The idea was simple: build a city center that would become a landmark. It wasn't about just another skyscraper. Those were already going up in Singapore, Hong Kong, New York. They needed something instantly recognizable, like the Eiffel Tower or Big Ben. At first, the plan was a tower around 550 meters, already a world record at the time. But projects in China and Saudi Arabia were already on the horizon. The competition wasn't sleeping, and Dubai knew. Build just 550 meters, and in a couple of years, it won't impress anyone. Before committing to a design, they held an architectural competition. There were proposals in the neo-modern style, glass rectangles, and others inspired by Arab palaces. But everything looked either too similar to other cities or too much like a museum piece. The winner was Adrian Smith's design. He had an edge. He proposed not just a tower, but a shape that combined beauty with function. The floor plan was like 3 petals radiating from a center. The inspiration? A desert flower called the spider lily. Everyone loved it. First, the shape looked elegant, with echoes of Islamic architecture. Second, this structure could handle wind loads without snapping like a matchstick. But all of this was still on paper, and rumors of even taller buildings were already circulating in Asia. That's when the game changed. The height was revised, first to 650 meters, then 750, and finally 828. Here's a fun fact. The final height was kept secret even from parts of the engineering team. Only a handful of executives knew the number. Engineers received blueprints in sections without context of the total height. Officially, it was to protect against competitors. Unofficially, to prevent media leaks before it was finished. And it paid off. In 2007, 3 years into construction, the tower had already surpassed Taipei 101, and they were still building. In 2008, the Burj Khalifa exceeded every radio mast, becoming the tallest man-made structure on Earth. Every new floor just cemented the lead, and at some point it became obvious. No one was catching up anytime soon. When you look at the finished Burj Khalifa, it's easy to forget that real people built it every single day under the desert sun and dust. This was a construction project that could have made history on its own. At its peak, up to 12,000 workers were on site every day. Just imagine, temperatures over 110 degrees Fahrenheit. Sandstorms could kick up at any moment, and down below, workers in hard hats and overalls, tools in hand, from 100 different countries. Dozens of languages were spoken on site, and sometimes just hand signals, because everyone shared one common language: the work. The harsh conditions conditions even sparked a riot in 2006. 2,500 workers went on a rampage across the site. A lot of equipment was damaged, but the next day, most came back to work. They didn't really have a choice. To put the scale in perspective, the project consumed 22 million man-hours. If one person tried to build it alone, it would take over 2,000 years. Materials didn't arrive by truck, they came in convoys. The Burj Khalifa used 330,000 tons of concrete, roughly the weight of 100,000 African elephants, and 39,000 tons of rebar. If you stretched it out, it would wrap a quarter of the way around the Earth. The aluminum in the tower weighs as much as 5 Airbus A380s, plus 24,000 glass panels on the facade, each one cut by hand. Lay them out and you'd cover 17 football fields. And all of it had to be not just delivered, but lifted. 3 Favco tower cranes stood on site, each capable of lifting 25 tons. These giants worked non-stop, day and night, 7 days a week. The cranes grew with the tower. Their masts were extended section by section until they reached heights where clouds touched steel. Just think about it. Concrete had to be pumped hundreds of meters up, and in Dubai's summer, temperatures hit 120 degrees Fahrenheit. Concrete sets in minutes in that heat and cracks. How do you even build in conditions like that? The solution? They poured concrete only at night and added ice directly into the mix to cool it down. That kept the concrete workable long enough to pump it to a record-breaking 601 meters, higher than ever before in history. Another record, by the way. The pace was relentless, a new floor every 3 days. The city watched the tower rise before their eyes. But behind that speed lay the biggest engineering puzzle. How do you plant a nearly kilometer-tall skyscraper on soft sand? A typical skyscraper in New York sits on bedrock. There's solid stone underneath. You drill piles straight into it, and the building stands rock solid. But Dubai has no bedrock for a skyscraper foundation. Beneath your feet, sand, soft rock, layer after layer, down to 100 meters. Try putting a nearly kilometer-high monster on that, and it'll just float away, like a stick in wet sand. The engineers knew the standard approach wouldn't cut it. They needed a foundation that could distribute the load and grip the ground. First, they poured a massive reinforced concrete slab nearly 4 meters thick, weighing as much as an aircraft carrier. It works like a giant shoe, spreading the building's weight so it doesn't press down on the sand at any single point. They used special concrete, nearly impermeable, so the salty groundwater wouldn't eat away at the rebar. And beneath the slab, they installed a cathodic protection system, essentially sacrificial electrodes that corrode instead of the metal inside the foundation. But the slab alone wasn't enough. First, they drilled 194 shafts, filled them with concrete and rebar, creating piles 1.5 meters in diameter, nearly 50 meters deep, reaching the denser soil layers. Each pile can support up to 3,000 tons. The whole system works like this. The piles grip the dense ground, while the slab spreads the weight evenly across the entire area. Even under the strong Arabian winds, the tower won't lean. In the end, the foundation beneath the Burj Khalifa supports 450,000 tons and doesn't let the building settle or shift by even a millimeter. But height looks great on paper. For engineers, every extra meter means more wind load hitting the walls. And wind in Dubai, especially 500 meters up, that's no gentle breeze. It's powerful gusts that can sway a building until people inside get sick and the structure starts to crack. The first 40 wind tunnel tests of the Burj Khalifa model revealed something terrifying. If they kept the walls flat, the building started swaying in rhythm with the wind gusts. Here's the thing, every tall building has a natural frequency, like a swing. That's normal. But if the wind starts blowing in sync with that frequency, the tower will sway harder and harder until it breaks. This phenomenon is called a vortex street. Wind flows around the building, vortices form behind it, and they hit the walls with a certain rhythm. The challenge was simple to state, but hard to solve. Make sure that rhythm never matches the tower's natural frequency. So the Burj Khalifa was designed so that wind never hits the same cross-section twice in a row. The shape constantly changes. The tower has 27 levels of different shapes. The floors spiral. 3 wings extend from a central core, and at each step, one wing gets shorter. The cross-section keeps changing, as if someone twisted the building during construction. This twist confuses the wind. Air flowing around one level hits a different shape at the next level, and the vortex never has a chance to build up strength. Engineers tested this on dozens of models, spinning them in wind tunnels at different angles and speeds. Every time, the twisted shape won. The tower stopped being a toy in the hands of the elements and started using the wind against itself. But even after solving the wind problem, there was one last enemy, and in Dubai, it can be worse than any wind: the heat. Dubai has two seasons: hot and unbearably hot. In summer, the asphalt melts, the air scorches, and you can only touch metal with gloves. Now imagine a steel and glass needle, nearly a kilometer tall, standing in the middle of that furnace. Without protection, the inside would be a giant microwave. So they made the tower's shell like armor against the sun. 24,000 panels, each with 2 layers of protection. On the outside, silver coating that blocks ultraviolet rays. On the inside, titanium coating that cuts infrared heat. The result? Solar heat is reduced by almost 70%. There's so much glass that the total area equals 17 football fields. And the entire surface is designed to reflect and scatter light, not turn the vertical city into a greenhouse. In summer, it gets so hot that the Burj Khalifa needs up to 10,000 tons of cooling at peak times. That's like melting 10,000 tons of ice every day, roughly 2 average icebergs every month. Water is another story entirely. You can't just pump water to the roof. That's nearly a kilometer of height difference, requiring impossibly high pressure. So they split the system into stages. A pump pushes water to the first level, where there's a storage tank that distributes water to the lower floors. Then another level higher up, and so on all the way to the top. Essentially, it's a series of water towers inside the skyscraper. Every day, the Burj Khalifa uses nearly 1 million liters of desalinated seawater. But here's the clever part: the condensate. You've seen how air conditioners squeeze water out of humid air in hot weather. Well, here they don't drain it. They collect it through separate pipes in the basement. It adds up to about 15 million gallons, 57 million liters per year. That's like 20 Olympic swimming pools. Instead of dumping this water, they reuse it, watering the park at the base and feeding the cooling systems. Economy, ecology, and logic, all in one package. But there were scandals too. The most famous myth? The sewage story. Photos circulated online of trucks lined up at Dubai skyscrapers to haul away waste, supposedly because the sewer system couldn't handle it. It looked like the tower had no sewage system at all, and everything was trucked out. In reality, the building has been connected to the city system from day one. Pure fiction. There are other small things that become serious problems at this scale, like dust and sand. The wind carries them constantly, and you've got a glass facade across 163 floors. A team of 36 industrial climbers washes the windows every 3 to 4 months. But as soon as they finish, they have to start all over again. Robots are used for some hard-to-reach spots, but most of the work is still done by hand. And so this vertical city learned to live in the desert. There are nearly 1,000 apartments here, plus a hotel, offices, restaurants, and lounges. Each zone has its own entrance, its own lobby, its own security. Even small details matter, like the 196 symbols inlaid in the lobby's marble, one for each nationality living in Dubai. And like any city, it needs its own transportation network. Only here, instead of buses and subways, 57 elevators. They're the highways of this vertical city. Some shafts even have 2 cabins, one above the other. Regular cabins just aren't designed for these distances. The cables would be too heavy. These double-decker elevators travel 504 meters non-stop, a world record. The elevator speed? 452 meters per minute. That's roughly 2.5 floors per second, faster than many subway trains. The tower is divided into levels, like neighborhoods of a city. On the 43rd and 76th floors, there are sky lobbies, transfer stations. You take a high-speed elevator there, then switch to another that takes you to your apartment or office. This prevents crowds and saves time. There are also special purpose elevators. 10 are designated for firefighting. They're kept under positive pressure so smoke can't get in. It gets pushed out of the elevator. These connect to refuge areas, special rooms designed to withstand fire and smoke for at least 2 hours, each capable of holding up to 500 people. The building's capacity? Up to 35,000 people at once. Without these elevators, evacuating down 3,000 stairs would take hours. Here, minutes. But 2 professional base jumpers found the fastest way down from the Burj Khalifa. They built a special platform right at the tip of the spire at 828 meters. The jump lasted about 90 seconds, and it's still the world record for the highest base jump from a building. That same spire was the setting for a viral ad. A flight attendant in full uniform standing on the very tip, on literally a square meter of metal at 830 meters. And it's not computer graphics. She was lifted by helicopter and secured with safety cables. The spire itself is about 200 meters tall and weighs just 350 tons, incredibly light for that size. It was assembled inside the building like a telescope and gradually extended upward as the floors rose. And in 2011, a climber known as Spider-Man decided to scale the tower from the outside. Yes, with bare hands, gripping ledges and metal seams. The authorities did insist on a safety harness. After all, it's nearly a kilometer high. The climb took about 6 hours, and the whole city watched from below. The Burj Khalifa even has its own central plaza at the base at the foot of the tower, and it cost $218 million. It's a musical fountain that shoots water up to 150 meters, roughly a 50-story building. It's choreographed to music and lit by nearly 7,000 lights and hundreds of projectors. But the real show begins when the tower itself becomes a giant screen. Built into the facade is a system of 1.2 million LEDs integrated right into the structure. Holidays, flags, greetings, all displayed on an 800-floor tall screen, visible from kilometers away. And the glass panels stay transparent from inside. Residents see the city, not the screen, as if the lights don't even exist. There's also a trick that doesn't require any technology, but amazes just as much. You're standing at the base watching the sunset. The sun goes down, day's over. Then you step into the elevator and ride to the top. A couple of minutes later, the sun is hanging over the horizon again. The time difference between sunset at the bottom and the top is 2 to 3 minutes. 2 sunsets in one evening. In the early 2000s, this was just land, heat, and sand. 6 years later, a city rising nearly a kilometer into the sky. 22 million man-hours, 100 nationalities, over 12,000 workers. A small town built this tower. 330,000 tons of concrete, the weight of 100,000 African elephants, and 39,000 tons of steel, enough to wrap a quarter of the planet, dozens of records, and a challenge to the very idea of what's possible. The fastest elevator in the world, the highest mosque, the highest swimming pool, all in one building. In the end, the Burj Khalifa became more than a record in concrete and glass. It became an icon around which stories constantly unfold. The tower became to Dubai what the Eiffel Tower is to Paris and Big Ben is to London, a symbol visible from dozens of kilometers away, impossible to confuse with anything else. And everything connected to this tower is always on the edge of possible. When you stand at the base and watch the Burj Khalifa disappear into the clouds, you understand. Here, they decided that this time, the sky is not the limit.